The ice drift forecast layer enables you to assess the current movement of the sea ice cover and predicts where certain ice features or the ice edge might drift over the next few days. In the Arctic, you can assess two different forecast scenarios, which you can activate or deactivate in the drop-down menu in the upper right corner. When zoomed out, ice drift forecasts appear as black and white lines. The black drift path is based on the so-called Topaz 5 sea ice model provided by the Copernicus Marine Service. Topaz 5 takes into account the most recent weather model forecasts, primarily wind, but also ocean current, coastlines, bathymetry, and the physics of sea ice. It predicts a drift path for the coming 9 days and is updated on a daily basis. The white drift paths are basically wind forecasts translated to ice drift by the simple assumption that sea ice drifts with 2% of the wind speed and deviated by 25 degrees to the right or left, depending on whether you are on the northern or southern hemisphere. In Antarctica, only the white wind-based forecast is available. Detailed information becomes visible when you zoom in. Always check the timestamp of the current ice drift forecast and update it with the refresh button if it is too old. The timestamp coincides with the first position on the drift path, the red square, with each subsequent dot representing the location change after 24 hours of ice drift. Why do we provide two different forecast scenarios, the white path and the black path? The reason is that with two independent forecasts, you can estimate a level of uncertainty. Uncertainty is inherent to each drift prediction. When both ice drift forecasts agree for the next 3 days, the chance that the predicted ice drift is correct increases. If both ice drift forecasts disagree slightly, you can take the distance between 2 points for the same day on both drift paths as a measure for an uncertainty. If two drift forecasts completely contradict each other, such as pointing in opposite directions, you may need to accept that a reliable prediction is not possible unless you have a strong reason to trust one forecast over the other. In general, wind-based drift forecasts are reliable whenever the ice is in a state of free drift, that is, not influenced by strong ocean currents, nearby coastlines, or other topographic features. If you have a good reason to disregard the pure wind-based forecast entirely for this position, because you cannot assume that the ice can drift freely, for instance, close to land, the Topaz 5 drift forecast could still be correct. Let's take an extreme example in the Canadian archipelago. In February, vast areas are covered in land-fast ice, meaning the ice remains stationary. In this case, you can disregard the wind-based forecast, as it does not apply. However, the Topaz 5 forecast remains valid, accurately indicating that the ice will not drift. In this example, within the East Greenland current, the two predictions initially disagree by 180 degrees on the first day. Given that the East Greenland current is a strong southward-flowing ocean current, this suggests that the purely wind-based forecast may be too simplistic and therefore inaccurate. The final example comes from Antarctica, specifically the northern tip of the Antarctic Peninsula. The eastern side of the Antarctic Peninsula borders the Weddell Sea, which is covered by ice year-round. However, shifting winds can temporarily clear the Antarctic coastline of ice. In this example, the date is February 12th at 1300 UTC. A Norwegian ice chart from 2 days earlier shows a small region with 100% sea ice concentration, indicating a large ice flow. A radar image taken 1 day and 13 hours ago shows that the ice flow drifted northward by approximately 5 nautical miles. In a more recent optical image, the same flow is visible through the clouds, having traveled an additional 12 nautical miles northward. It appears that the window of opportunity for operations in the Weddell Sea is closing as the ice drifts toward the coast. What happens next? The ice drift prediction begins today, February 12th, at midnight, roughly the same time the optical image was taken. At the moment we are reviewing the forecast, we are 13 hours ahead of the forecast timestamp. This places us roughly halfway between the red square and the first dot, as each marked position on the drift path represents a 24-hour interval. According to the prediction, the northward drift will continue for another 12 hours before slowing down the following day. In 2 days, the drift is expected to reverse, moving southward. It is important to recognize that every drift forecast, like any weather forecast, can be inaccurate, especially in remote regions. Therefore, never base life or death decisions solely on weather or drift predictions. Forecasts should be considered as just one of many information sources to support your decision-making. Always plan with the understanding that, in the worst case, conditions may unfold very differently than predicted.